Okay, so we talked about the meaning of yield. We described a model. Now we're going to go into the equation, which is based on the model, and then talk about how it applies to different resources and ecosystem and its difference between that and sustainability. Okay, so we have the different variables, and we know what they are called. Births, in migration, I need to speed that one up. Uh, then natural deaths over here. The population does not enter the equation. I'll talk about that in a minute. Natural deaths, harvest, and emigration. Births, in-migration, natural death, harvest, and emigration. So which ones are outputs? These three are outputs. These two are inputs. The green ones are inputs. The red ones, red and orange, are outputs. Okay, so we know that inputs have to be greater than outputs. So these two are inputs above the white line, births and in-migration. Then below the line will be the outputs. These are green, these are red. So there's death and emigration and sustained yield, or the harvest. So we have three outputs and two inputs. And we know that these inputs have to be greater than the outputs. So those are in and those are out. So now let's list them horizontally. We have births plus in-migration, and that has to be greater than or equal to. There are times when we actually want to keep a population at one level, and if we want to keep it right where it is, we would be more likely to keep these two things equal. Okay, so births plus inputs plus in-migration has to be greater than or equal to deaths plus emigration plus the harvest, or sustained yield. Then we want to solve for sustained yield because we want to isolate that, because that's what we're looking to figure out. You will do studies to determine what the deaths are and how many are in-migrating, how many are dying, and how many are leaving the population or emigrating. So we'll know those four variables, and we solve for the last one, which is how much we can harvest. What's left over is what we can harvest. So births plus in-migration minus deaths minus emigration, because we have to subtract D from that side, and we move E to this side and subtract it. So we have B plus I minus D minus E has to be greater than sustained yield. So this is called the BIDE equation, and BIDE is only for these first four variables: births, in-migration, deaths, and emigration. This is the BIDE equation for sustained yield of wildlife. What is left over after you add births and immigration and take out the deaths and emigration? These are the ones coming in, births and immigration. These are going out, they died or they emigrated. What's left over is your sustained yield. So BIDE is also called sustained or net growth. Net growth. So net growth includes all the variables except human harvest. Net growth includes all those variables, B, I, D, and E, and you know what those stand for, and all of those except for sustained yield. So the equation for net growth is inputs have to be greater than outputs, or for a forest, inputs would be the growth of the trees in the stand, outputs would be the mortality of the trees in the stand. So then net growth in a forest would just be growth minus mortality. Remember that we didn't have in-migration, we didn't have out-migration. Let's go back and look at that model again. Okay, we don't have in-migration in a forest, we don't have out-migration. In a forest, we're just going to have the growth and the mortality, and this, instead of hunting, we're cutting the trees down. So we have the dead trees here, and these would be seedlings joining the population. And so in the sustained yield of a forest, we just take birth or growth, we call it growth, minus mortality, and that's how many we can cut. So it's a different, Oh, well, we have to go through that again. I guess it's going to be a review: natural death, human harvest, and emigration. So, net growth in a forest is just growth minus mortality. And it's the same for fisheries population, unless you have significant in-migration and out-migration for a fisheries population. So we know that BIDE has to be greater than sustained yield, and that BIDE is also equal to net growth. I usually use a greater sign here, but there are times, as I said before, that you will want to hold it right at the same population level and not let the population grow. So then we want it to stay equal. We want to harvest what's left over. So then we can substitute. We know that BIDE equals net growth, and BIDE also equals sustained yield. So we also know that net growth is greater than, can substitute net growth for BIDE, and we get net growth is greater than sustained yield. So there's two ways to look at sustained yield equations. It would be either BIDE has to be greater than the harvest, or net growth has to be greater than the harvest. BIDE is used for wildlife populations, and net growth is used for fisheries and forestry. So in this case, in forestry and fisheries, net growth is equal to what? Births minus deaths, growth minus mortality, the BIDE or the stock. So in this case, and this could be a question on a test, and I think you'll know right away here that net growth has to be equal to growth minus mortality. We don't really talk about births of trees, right? Or deaths of trees necessarily. So we talk about growth minus mortality. So the answer to this one is B. So the harvest is, and we're just reversing it now. So sustained yield has to be less than net growth. This way I can ask the same question in slightly different ways. It's kind of the same question, but asking it in slightly different ways often confuses students. So in wildlife management, the sustained yield is less than what? Try to think about it for a moment. What would it be less than? If you found that question on a test, what would you answer? Would it be births, deaths, harvest, or BIDE, which is births plus in-migration minus deaths minus emigration? And of course, the answer is D, BIDE. We want all of those. We want to take births and immigration, subtract the deaths, subtract the emigration. What's left over, we can harvest. Okay, is BIDE equal to net growth? In that case, it's true. Yes, BIDE is equal to net growth, and it's also equal to sustained yield. Sustained yield equals the harvest. Is that true? Yes. In this class, we'll use sustained yield and harvest interchangeably. We don't want that harvest to be any different than the sustained yield. If it's greater than sustained yield, that is exploitation. It's not harvest. So sustained yield is a way of capturing what? Can you remember what that was? Sustained yield is a way of capturing what? And it was Gifford Pinchot who talked about sustained yield as capturing mortality. Sustained yield is a way of capturing mortality. So what he meant was that for individuals that are going to die anyway, such as an old bull moose, an old ram, we know they're not going to last very long, and in fact, an old bull is no longer contributing to the population, so taking that one out is an easy way to find the one that's going to die anyway. With other things like ducks, you can't be so sure which one would have died anyway or is about to die, unless it's clearly limping or something like that. Okay, so sustained yield is a way to capture mortality, and he even asked the question, would you leave corn in your field to rot? So then, no. So why leave trees there to rot? So you can understand why he felt that leaving trees to rot was a waste. But then Leopold came along, and he was one of the first ones to argue that that we should leave some dead and down trees in the forest. Don't take them all. You know, if you harvest a tree soon enough after it dies, you'll be able to save all the wood in it. But if you wait very long, then it's going to start rotting. So foresters would, or loggers would like to get in there right away and harvest those dead trees. But Leopold showed us that it's not good to take all. But we didn't actually institute that in forestry in this country until the early 1990s. It was very controversial whether we should just leave dead trees out there. Now there are requirements that some dead and down trees be left in a forest when you log it. So what's the difference between net growth and bide? They actually represent the same concept. They're just different terminology. So it's kind of confusing for students new to this because it seems like they'd be totally different things, but net growth and bide are really the same thing. It's just that this one uses slightly different terminology and also has immigration and emigration in it. So the maximum amount then that you can harvest is net growth. The maximum you can harvest is net growth because you want to take births minus deaths, inputs minus outputs. So does the stock enter the sustained yield equation? So you know we had that tank in the middle of the model. Now, that was the stock or the population. Is it in the sustained yield equation? Have we put it in there? The answer is no. The stock or the population does not enter the sustained yield equation. So the size of the stock doesn't directly affect the harvest. Only the net growth rate affects the harvest in this model. So there are more complex models where you can add the size of the stock, and we'll talk about that in a bit. But in this model, you're going to know the net growth. So stock does influence the amount of net growth, but this is the key variable. You want to know this, and then you can set the harvest. Net growth has to be greater than or equal to harvest. Okay, as the stock approaches carrying capacity, remember that K is carrying capacity, the growth rate's going to decrease. We'll talk about this more in a moment. So, you know, if this starts filling up and there's no room for any more fish, it's definitely going to decrease the growth rate. So the population density is getting very great. There's not as much light in there for vegetation to grow. The growth rate is going to decrease, but it's an indirect effect. It will affect, this feedback loop will affect the growth rate and decrease it. But it's not a direct effect, so it does not enter the equation. So you can see that here's the stock of population, but it's not entering either equation, the equation for forests or the equation for wildlife. And part of the reason that we emphasize this is that it doesn't matter how big the stock is. If outputs, these, are exceeding inputs, then the population will be shrinking. It won't last forever, which is what we want. So you harvest the interest and you don't touch the principal. This tank is the principal. So as long as harvest is less than net growth, the stock will grow despite very high harvests. Is that true or false? As long as harvest is less than net growth, you're harvesting less than net growth, the stock will grow despite very high harvests. And that's true. It's still going to grow. You might have record high harvests, but this thing is growing faster than you're harvesting it. So you can harvest a lot. The larger the stock is true or false? The larger the stock, that tank in the middle, the larger the sustained yield of that resource. Most people would think that's true, but it's not. It is definitely, this one is false. It doesn't matter how big the stock is. Because I'll show you in a moment. Here's a village has a lake with a population of 5,000 fish growing at 30% a year. That's very, very fast. Village B has a lake with 50,000 fish, 10 times the number of fish, growing at 2% per year. So in order to figure 30%, some people have a problem with that. What I do is first figure out what would 10% of this be. So 10%, you just move the decimal place over 1. And so 10% would be 500. And then we need 3 times that, because this is 30%. So you take 500 and multiply by 3, and you get 1,500 per year. So that would be the number of fish you could harvest out of this lake with 5,000 fish in it. Village B is growing at 2% per year. So we take, now we want to find out what 1% would be. And again, we move it, for 1%, we move the decimal over two places. 1, 2. 2 places. So again, it's 500. And we multiply by 2 since it's 2, not 1%. So then that is 1,000 per year. So here's a lake with 10 times as many fish in it, but it's growing more slowly, so you can't harvest as many as you can with this little population. So A has a yields greater than B, even though the stock, that tank in the middle, is far bigger. So why would that be? If you think about it, when this lake fills up, let's say these 2 lakes are about the same size, this one's going to be very, very full of fish. They're not going to be growing very fast. And so that population actually yields less than the other population. And I'll talk about this more when we get to part 3.